Introduction to Auxiliary Views. We have studied about orthographic projection and isometric views in the previous video. Here in this video, we have come with another view. So let's start. Before starting, just think about cars. We can see the top view, front view, and side view of the car. But we can see here one more surface, that is inclined windscreen. Have you ever thought to project a car on a flat sheet with exact shape and dimensions? If yes, then were you able to project the inclined windscreen on the sheet? So, in this video we are going to discuss projecting the inclined surface with exact shapes and dimensions. So, as we know that the principal views of an object can be projected using orthographic projection, principal view means top, front, and side view. But orthographic projection cannot represent the inclined view of an object. So here is another method to represent inclined surfaces. In engineering drawing, to represent the slanted or inclined part of an object, an auxiliary view is used. So defining auxiliary view, we can say that auxiliary view is used to determine the true shape and size of the inclined and oblique surfaces of an object. It is a kind of view that is projected in auxiliary planes. Now the question arises, what are auxiliary planes? Basically, auxiliary planes are of two types. Auxiliary inclined plane, it is perpendicular to VP and inclined with HP at some angle, and projection on AIP is also known as auxiliary plane or auxiliary top view. Auxiliary vertical plane, it is perpendicular to HP and inclined with VP at some angle, and projection on AVP is known as auxiliary elevation or auxiliary front view. Now the question arises, where and why do we need auxiliary view? For this, let's take an example. Here in this image, the object is placed in the first quadrant. All principal views, they are top, front, and side view are projected in profile planes. We can clearly see the top, front and side view of the object. But there is a portion of the object which cannot be projected in the profile planes. We can see that none of the principal views gives the true shape and size of the surface. So to represent the true shape, auxiliary view terminology is used. I hope it is clear why we need an auxiliary view. Now the question arises, how will we get an auxiliary view? The answer is that we can set up one or more planes which are parallel to the inclined surface. This plane is termed as an auxiliary plane. Clearly, we can see that the true shape of an inclined surface of an object is projected on an auxiliary plane. Now we can project the image of the inclined surface of an object in the auxiliary plane to get its true shape and dimension as shown in the image. We have basic procedure to project auxiliary views. So if we will follow this procedure, we can project an auxiliary view of any problem. This procedure is like so. Step 1. First, draw the top, front and side view of the object. Step 2. Draw a line x1, y1 which is an auxiliary plane parallel to the inclined surface, which will be inclined at some angle to the reference line xy at any distance. The x1, y1 line is the auxiliary plane. Step 3. Project the endpoints of the inclined surface perpendicular to x1, y1 and extend the projectors above x1, y1. Now measure the dimensions of endpoints of the inclined surface ABCD from principal views, that is, measure distance between ABCD and mark them on projectors above x1, y1. Now in step 4, join the obtained points A, B, C and D which will be the required auxiliary view of the inclined surface with true shape and dimensions. This is all about auxiliary views in an engineering drawing. Now by this information we can easily project the inclined surface of a car, that is windscreen, on a flat sheet with its true shape and dimensions. So in this video we have studied what actually is an auxiliary view. In the next video we will come with some problems related to auxiliary view.